All right, hi everybody. In this video, I want to do kind of a quick refresher about how to handle units and unit conversion factors and stuff like that. Something that we'll be doing very often in the course. I'm sure you know already how to do unit conversions, some method of how to do unit conversions. Let me show you the way I like to do them, and you can do them this way if you like. It's kind of a more systematic approach that works for me. So that I don't make mistakes when I'm doing unit conversions. The key idea in this approach is that when you're working with units, they are just simply algebraic quantities that you can handle in exactly the same way as variables. There's nothing special about units. I feel like when I was a student, I used to feel like when there were units attached to a number, that those units were some kind of special thing that was different from a number and was different from an algebraic variable and had to be treated by some kind of unique rules, which no one ever taught me. But that's not the case. You can handle units exactly the same way that you handle other kinds of variables. They can get multiplied together, they can get divided, you can do algebraic manipulations on them, and so on and so on. But once you realize this, unit conversions are really just simple algebraic manipulations. So let me give you like an example of this. Let's say I wanted to convert, 16 centimeters to units of micrometers, let's say. You might be able to do this in your head, but just say that you had no idea what the answer to this is. Say you didn't have access to Google to just do the conversion for you, and you want to do this, as my intro physics teacher used to always say, you're stranded on a desert island and you have to do this problem. Okay, what are you going to do? Well, the first thing I remember off the top of my head is that 100 centimeters equals 1 meter. Okay. So say that's something that you remember or a given piece of information on the formula sheet or whatever the case may be. How are you going to use that information? So the first thing is, just to kind of go through this really step by step, if 100 centimeters equals 1 meter, that is an equation. That is an algebraic equation, which I am allowed to fiddle around with as long as I respect the rules of algebra. So what I am going to do is divide both sides of this equation by 100 centimeters. You have to do it to both sides, of course. And then the left-hand side, I have the same thing in the numerator and denominator, so that just becomes 1. And the right-hand side becomes 1 meter over 100 centimeters. So 1 meter divided by 100 centimeters is equal to 1. Why does that matter? Because you can multiply something by 1 and it doesn't change its value. So if you multiply a quantity by 1, you're not changing that quantity. When you're doing a unit conversion, you don't want to actually change anything. You just want to fiddle with the units only. So the way to do that is basically you keep multiplying by 1 until you get what you want out of it. So like what I can do is take 16 centimeters. Let me just start with the world's simplest equation, okay? 16 centimeters equals 16 centimeters. Obviously, that is true. Now, what I want to do is I can multiply one of these by 1, and it won't change the value. So let's say we fiddle around with the right-hand side. So we have 16 centimeters equals 16 centimeters times, I want to multiply it by 1. But I want to multiply it by 1 in the form shown on the left. I'm going to multiply it by 1 meter divided by 100 centimeters. And since I'm multiplying by something that is equal to 1, as we proved over there, it's not going to change the value. Now, since the units here are just algebraic quantities, I can treat them using the normal algebra rules, one of which is I have up here centimeters in the numerator and centimeters in the denominator, so those are going to cancel out. But the meter does not cancel out. So then I end up with 16 times 1 divided by 100, which is 0.16. And the only unit I'm left with is meters. So I have 0.16 meters. So I end up with, somehow my pen width changed here, but that's okay. Somehow I end up with 16 centimeters equals 0.16 meters. And you notice that is a true conversion. We ultimately wanted to get to micrometers though, so that means we're not quite done yet. The other unit conversion I remember is that 10 to the 6 micrometer equals 1 meter, because that's micro is 10 to the 6. So now I'm going to do the same thing again. If 10 to the 6 micrometer equals 1 meter, now this time I want meter to be in the denominator because I want the meter to cancel out. So I'm going to write it as 10 to the 6 micrometer divided by 1 meter equals 1. Now we'll do the same thing. Multiply by this quantity that I just worked out. So now I'm going to have, we'll start out with 0.16 meter equals 0.16 meter. And now I'm going to multiply one side by 10, oops, it's a little bit messy, 10 to the 6 micrometer over 1 meter. As before, meter cancels out. So there's my actual unit conversion happening. And then I have over here, I'm going to have 0.16 times 10 to the 6. That will be 0.16 is 1.6 times 10 to the minus 1. So this is going to be 1.6 times 10 to the 5 micrometer. And that's equal to 0.16 meter, which is in turn equal to 16 centimeter. So there's my unit conversion happening. 16 centimeters is equal to 1.6 times 10 to the 5 micrometers. Okay, so you can see the process by which this happened here. We're really just multiplying by this conversion factor. And that's the basic idea of how I do unit conversions personally. You don't have to do it exactly the same way as me, but if you don't have a systematic method that you're comfortable with, consider trying out this one.